Okay. So yesterday we solved a bunch of equations in our notes. Today we're still going to be solving some equations. Oops, we did some of those right here. We're going to be solving a slightly different type of equation. This uses the skills for being able to solve linear equations. It's just going to look a little different. If you look at our examples here, you'll notice these are not one variable equations. They definitely have more than one variable. These two equations you see here at the top, D equals RT and S equals KR squared plus KRL, those are what are called literal equations. Literal equations are equations that have multiple variables, so they can have more than one variable. And the variables actually represent quantities. So you may or may not have seen these equations before, like you might have seen this one in Algebra 1 or in a science class. This is D equals RT is representing distance equals rate multiplied by time. Or this one you might have seen in geometry, S equals KR squared plus KRL. This is a surface area formula, I think, for a cylinder. Obviously, if you didn't know that, it doesn't matter. We can still solve the equation. But that's what a literal equation is. It has multiple variables, and it's the variables represent specific quantities like distance or like radius or something like that. So what we can do on something like these, on these literal equations, is that we can isolate a specified variable. And we would say we're solving for a variable, but really we're trying to isolate. So isolate a specified variable is what we're trying to do. Okay, so we're gonna do some examples of these. And you'll see we're using the same skills we do with other linear equations. All right, so write down the equation in number 7, D equals RT. That's the equation. And then it says for T. So we're trying to solve for T. So if you hear the expression solve for T, it's just going to mean that we're trying to isolate T. We're trying to get the T by itself. In this equation, D equals RT. The R and the T right next to each other that means they're multiplied. This is R multiplied by T. So we're trying to get the T by itself. So I'm going to keep the T where it is. That means I have to get rid of the R. This is R times T. So the opposite of multiplying by R, the inverse operation, would be dividing by R. So to get rid of that R, I'm going to divide by R. But it's an equation, so of course, whatever I do to one side, I do to the other. So if I divide both sides by R, on the right side, the R divided by R gives us a 1. So all that's left is T on that side. So then I have D over R equals T. So as you can see, the T is actually already by itself. So we're actually done with this problem. However, when we write our answer, usually, again, I wouldn't mark you wrong if you wrote it this way, but usually we would write the variable that's by itself on the left so that it's in the form T equals D over R. As you can see, those are exactly the same thing. This is just the more common way to write it. Okay, so that's all we're trying to do on a literal equation. If there's not numbers and we can't solve for x, notice our answer isn't a number like x equals 3. Our answer is an equation that's in a different form. T equals D over R. All right, let's look at number 8. So write down number 8 in your notes. The equation is S equals KR squared plus KRL. S equals KR squared plus KRL, and we're solving for K. So that means we want to isolate K, or get the K by itself. So if we look at this, there's two K's, a K here and a K here. They're both on the same side of the equal sign, which is good, but we need to see if there's a way we can isolate that. One skill we can use that we used previously when we were reviewing is you might notice that both of these terms have a K in it, or in other words, there's a GCF. So what I'm going to do on this right side here is I'm going to factor out a GCF. Now, technically, they have a K and an R in common. So you could factor out both a K and an R. I'm just going to factor out a K right now, because remember, that's what we're trying to get by itself. So I'm going to factor out a K out of this side. So I'm going to divide both terms by K. And if we factor out a GCF, don't forget that we still need to put that, I'm going to move that over so I have room. We still have to put the GCF in the front. So the K would go in the front. And then inside the parentheses, this would give me R squared from this term plus, here the K would divide out and we'd be left with RL. Okay. And the left side of the equal sign is still S. So all I've done so far is factor out a K. And even though I could have factored out a K and an R, since I'm trying to get the K by itself, I only factored out the K. So I have S equals K times R squared plus RL. Okay, now, like I said, we're trying to get the K by itself. This K is multiplied by R squared plus RL. So the opposite of multiplying by something, to get rid of it, or the inverse operation, I can divide. So I'm going to divide by R squared plus RL. And of course, whatever I do to one side of the equation, I have to do to the other. So I have to divide both sides of the equation by R squared plus RL. The reason we do that is because now on this side, the R squared plus RL will divide out, and the K will be by itself, which is what our goal is. So again, if we write it in the same order, we have S over R squared plus RL equals K. This is completely correct, but again, usually if we're isolating a variable, we like to put the variable by itself on the left side. So instead of writing it in this order, I'm just going to switch orders and put K equals S over R squared plus RL. Okay. Now, one thing I do want you to notice about the way I wrote this, when I write it as with a fraction bar, with a separate numerator and denominator, I didn't really need to write the parentheses around the R squared plus RL, because the way it's written, it is clear the way that it's already grouped. If you were typing this to me though, you would have to use parentheses. So S divided by, and then you would want R squared plus RL in parentheses. That way you can tell that the S is the only thing in the numerator and the R squared plus RL is in the denominator. Because when you're typing it, it's much harder to tell which part is which. All right, so those two are actual literal equations with only variables, no numbers. If you look at 9 and 10, these are still two variable equations. They still have multiple variables, but they have numbers as well. And in this case, X and Y don't represent anything specific, like in this problem, the distance, rate, and time, or the height and the surface area and the radius. So These aren't technically literal equations, but we use the exact same skills and we do deal with these later on. So I did want to do a couple like this. All right, so let's look at number 9. So write 9 down in your notes. On number 9, we have negative 4x plus 6y equals negative 12. And I did not write down what variable to solve for. So I'm going to tell you now, we're going to solve for y. So that means if you see the word solve for y, that means we're trying to isolate the y or get the y by itself. You would have definitely seen equations like this, both in Algebra 1 and Algebra 2, but it's a good skill to review. So if I'm trying to get the y by itself, here's the y. I'm going to need to get rid of the 6 that's multiplied by it. But before I can get rid of the 6, I have to get rid of this negative 4x that's added to it. So the way I would get rid of that negative 4x, we still use our adding and subtracting or using our solving equation skills. To get rid of this minus 4x, I would need to add 4x to both sides. Because of course, whatever we do to one side, we do on the other. So on the left side, the minus 4x and positive 4x would add up to 0. And then we would just be left with 6y equals. On the right side, I can't combine those because the negative 12 does not have an x and the 4x does. They're not like terms. So we just have to write them both. Like this, negative 12 plus 4x. Or you can also write it 4x minus 12. It doesn't matter which order you write those in. Okay, and then I am still needing to get rid of this 6 that's in front of the y. So to get rid of the 6, this is 6 multiplied by y. I would need to divide by 6. Now there's quite a few different ways we can write our answer here. If I divide by 6, I have to divide this whole side by 6. Some people prefer to put the whole thing over 6 like this. If you do it that way, the 6's would divide and we would be left with this. Y equals negative 12 plus 4x over 6. Okay, this is technically correct and the y is by itself, but you might notice that some of these numbers can reduce. So I'm going to talk about another way we can write this. Another way we can write this is I can put both terms rather than putting the whole thing over 6 and making one big fraction. I could divide each part individually by 6. So the negative 12 divided by 6 and the 4 divided by 6. Some people like this because then our numbers reduce or divide. Like this, negative 12 divided by 6 is negative 2. And here, 4 divided by 6, it doesn't reduce, it doesn't divide, but it does reduce to 2 over 3. So then we would have this, y equals negative 2 plus 2/3 x. Okay, those are both correct and both equivalent. And unless you are trying to do more things with this, like graph it or find the slope, which we're not going to, you don't have to write it in this form. Now, once again, I want to talk about how you would type this. The way it's written right here in this example, in the first one, when I write it as a fraction bar with a top and a bottom, you can clearly see what's on top. Since you can't type it like that when you respond, I actually would need to put the top, the negative 12 plus 4x in parentheses, and then divided by 6. That way it doesn't look like only the 4x is divided by 6. We know the whole expression is divided by 6. Okay, now, if you didn't type that correctly, as long as I could know what you mean, I probably wouldn't mark you wrong, but when you have to type things, we kind of got to think about how we should type them, since we can't necessarily type them the same way we would write them. All right, we're going to do one more example, number 10, and then we'll try a practice problem. before we finish the last part of the note. Okay, so number 10, we have x squared plus y squared equals 25. Now, the goal, once again, is I'm going to have you solve for y. So we're going to try to isolate the y. We're going to have to use some of the skills we have been using, but you'll notice there's another skill that we're going to have to use to get rid of the squared part. So if I'm trying to get the y by itself, here's the y. I am going to have to get rid of the squared, but before I can get rid of the squared part, I have to get rid of the x squared that's added to it. So to get rid of x squared, I would have to subtract x squared. And of course, whatever I do to one side, I do to the other. So here, the x squareds would divide or would add up to 0. And we would be left with y squared equals 25 minus x squared. Okay. Now, we are going to need to get rid of the squared. So I'm going to need the inverse operation of squared. And I bet some of you remembered it. We did talk about it. The inverse operation of something squared is a square root. So I am going to do a square root of both sides. One other thing that I want to remind you about that you would have talked about probably in Algebra 2, but I know it's been a while. When something is squared, there's actually two numbers that would make this true. A positive number squared and a negative number squared both give us the same answer. Which means anytime we do a square root, which is what we're going to want to do here, we have to remember to include a positive and negative, a plus or minus in the front. All right, so to get rid of the squared, I'm going to do a square root, and whatever I do on one side, I have to do on the other. So I'm doing a square root of both sides. And also to remember that we can have two answers that give us the same thing, a positive and a negative. We put a plus or a minus in the front. So when we do that, here, the square root and squared get rid of each other, so we're just left with y. And then on this side, we would have positive or negative square root of 25 minus x squared. Okay. And this is actually all we can do on this problem. Now the y is by itself, so that's how we would write our answer. Y equals plus or minus the square root of 25 minus x squared. One thing, a common error I sometimes see is people try to simplify this by, because the 25 is a perfect square. Notice these are subtracted though. So some people try to put these each under their own square root and simplify each separately. That does not work because of the minus sign in between. That property only works if these were multiplied by each other. If they were multiplied, that would work. Here they're subtracted, so I can't actually simplify anymore. Okay, so just something I wanted to point out. Okay, so we're going to, before we finish the notes, we're going to try a practice problem. So our steps to solving application problems. The first thing we want to do, even though this is obvious, some people still try to like skip it over or do it too fast. The first thing we want to do is read the problem. So make sure you read it before you try to write any equations or do anything else. Just make sure you read the whole problem. So number one, step one, read. Step two, this is important, and a lot of people sometimes gloss over this step as well. Step two is we want to identify the variables. Identify variables. So that means you decide what variables you're using, and you want to say what they're standing for. So step two, identify variables. Step three, we have to take all these sentences and translate them to math equations. So we have to look for keywords that represent mathematical symbols. So step 3, we want to translate to math. So instead of word sentences, we want to have math sentences or math equations. So step 3, translate to math. Then step 4, we should be able to solve. So we should be able to write our equation. So step 3, translate to math. That's actually writing the equation. And then step 4 is to solve. All right. So we're gonna do, there's 2 examples on here. Hopefully we'll have time to do both and also do a practice problem. We'll just kind of see what we have time for. All right. So this is the first example we're doing. So I'm going to give you a minute to write it down. I know if you don't have a printer and you got to write it down, the word problems take a while to write down. So start writing down the problem. I'm going to read it a couple times so you can write it down. The length of a rectangle is 2 inches more than the width. If the length and width are each increased by 3 inches, the perimeter of the new rectangle will be 4 inches less than 8 times the width of the original rectangle. Find the dimensions of the original rectangle. Okay, so as you're writing it down, feel free to abbreviate words like rectangle or perimeter, so it doesn't take you as long to write it down. The length of a rectangle is 2 inches more than the width. If the length and width are each increased by 3 inches, the perimeter of the new rectangle will be 4 inches less than 8 times the width of the original rectangle. Find the dimensions of the original rectangle. Again, I'll give you a minute to finish writing that down, then we'll solve it. Okay. Hopefully you had time to write that down. Let's set this up. Okay, so I read it to you a couple times, so we want to make sure we always read the problem. So we did step 1, we read it. Okay. Now step 2, we want to identify the variables. When we're identifying the variables, the most useful thing is to usually look at the very last sentence, which is usually either a question or it's telling you what you want to find. So this last sentence tells us what we're trying to find. Find the dimensions of the original rectangle. So that helps us figure out what we're trying to find, which helps us figure out what variables we're trying to use. So dimensions are talking about length and width of the rectangle. I'm just going to use L and W. So I'm going to use L for length of original because it's the length and the dimensions of the original rectangle. And I'm going to use W to stand for the width of the original. Notice I abbreviated original, so I don't have to write it all out. You could use X and Y, you could use A and B. It doesn't matter what actual letters you use, you just want to say what they stand for. Okay, so L, I'm just going to use L and W. So step 2, identify the variables. L is the length of the original and W is the width of the original. Okay, now this one is actually, there's a lot going on here because we have the old rectangle or the original, and then we have the new rectangle. So one thing we know though is we're talking about the perimeter. So I do have to have a formula for perimeter. And so I'm sure you remember perimeter means we're adding the side length. So I'm adding L plus W plus L plus W. Or in other words, I'm adding 2L plus 2W. Okay. So perimeter equals 2L plus 2W. This is just a basic formula we already know, but we can use it to help us write our equation. Okay, now we're going to start translating some things into math. I'm going to be highlighting some things and using some different colors so we can tell what we're working with. Okay, so the first sentence, I'm just going to read this through and then translate as I go. The first sentence says, the length of a rectangle is 2 inches more than the width. So that allows me to write an equation. I'm going to translate this into math. So length, I'm using L, is like the equal sign, 2 inches more than the width. I could write that as W plus 2. So I'm going to translate this. This sentence is going to translate to L equals W plus 2. So the length is 2 inches more than the width. Okay. So that comes from this sentence. Now, reading on, it says, if the length and width are each increased by 3, the perimeter of the new rectangle will be 4 inches less than 8 times the width of the original rectangle. So this gets a little confusing because we're talking about the new rectangle and the old rectangle. So first, I'm going to write a perimeter for the original rectangle. So this one's for the original rectangle. Using the perimeter formula, the one thing I can do is I could take this expression for L equals W plus 2, and I can replace this L with the W plus 2. So P equals 2 times W plus 2. So that's the same as 2L plus 2W. So that's our original rectangle. So I used this sentence here, L equals W plus 2. So I replaced L with W plus 2. Okay, now let's do the new rectangle. Okay, there's a couple of things we're gonna have to do here. The first thing is the length and the width are each increased by 3. So that means I'm gonna have to add 3 to the length, and I'm gonna have to add 3 to the width. Okay. So now the right side of my equal sign, leave some space here for the left side. We're gonna have to deal with this in a second. But the right side of the equal sign, I'm gonna add 3. So here, instead of having W plus 2, I'm adding 3 to that. So now I'm gonna have W plus 5. And here, I'm adding 3 to the W. So I'd have W plus 3. So I have the perimeter equals, P equals 2 times W plus 5 plus 2 times W plus 3. So far I've did this part. The length and the width are each increased by 3. Now we have to do the other side. The perimeter, so here's the perimeter. The perimeter of a new rectangle will be 4 inches less than 8 times the width of the original rectangle. So the perimeter, this side, is going to be replaced with 4 inches less than 8 times the width. So we got to be careful the way we write that. The way we're going to write that is we're going to write 8W, that's 8 times the width of the original. Remember, W was the width of the original, minus 4. So I'm not going to write it as 4 minus 8W. It's 8W minus 4 because it's 4 less than 8W. Okay, so that's the perimeter. And it's equal, we already wrote this side of the equation. So equals 2 times W plus 5 plus 2 times W plus 3. Okay. Now, if you look at this equation, we have written an equation that only has W's in it. Now we will actually be able to solve for W. Okay. So this is part of the problem, is being able to write the equation. So this is in the form P equals 2L plus 2W. We just replaced everything with W's. Okay, now we can solve this. If I was solving this equation, I need to simplify the left side here. I would need to distribute the 2. So on this side of the equation, I'd have 2W plus 10 right here. And then here I'd have plus 2W plus 4. And so if I combine those terms, on the right side, I'd have 4W plus 14. Okay, so the left side, I'm going to write my work up here because I ran out of room there. The left side is 8W minus 4. The right side is, if I combine like terms, would be 4W plus 14. Okay, after we simplify, now the rest is just solving. So we should hopefully be able to solve fairly easy on this. So let's solve. To solve, I need to get the x's on one side and the numbers on the other. It doesn't matter which, it doesn't matter which side. All right, so what I'm going to do that, on the left side, I want to get rid of the minus 4. So I'm going to add 4 to both sides. Oh, I have a mistake. Does anyone see my mistake? I just noticed that before I solved. Yeah, I totally copied this down wrong from this step to this step. Esperanza caught that. I don't know if anyone else did. This is my fault. I copied it down wrong. Right here, it's still supposed to be W plus 3. So then this would be 2W plus 6. Okay. So then this is 2W or 4W plus 16. All right. Fix all those. That was my error because I wrote it down wrong between this step and this step. I copied it down wrong. So sorry about that. All right, this is what we should have. So 2W plus 6, and then if I add those, I have 4W plus 16. Now let's solve. I'm adding 4 to both sides to get rid of that minus 4. And then from the right side, I am subtracting 4W to get the numbers only on the right. So if I do that, I'll have 4W equals 20. And then I can divide by 4 and we get W equals 5. Okay, so we have actually part of our answer. Okay, W equals 5. But remember, we were trying to find the dimensions. So not only do I need to know the width, I also need to know the length. So that's where our original formula, this was the very first formula we wrote, L equals W plus 2. I need to use that. And so if width is 5, the length is W plus 2, so the length is 7. Okay, so you could write your answer. You do want to include both of these for your answer. Width is 5 and length is 7. Or another way to write dimensions, these are in inches. Another way you can write it is 5 inches by 7 inches. So that would be another way to write the dimension, 5 by 7. Okay. So before we do the last example, we're going to do a practice problem that involves perimeter. It is actually the ones that you are going to do are probably going to be a little more simple than this. This was pretty challenging because it had the original and the new rectangles. So we're going to try a practice problem. So you can put your notes to the side and try the practice problem, or you could keep the practice problem in your notes.